All right, fantastic. I know we've had a lot of excellent talks so far about hacking-related things, breaking into things, defending things, but looking out across this audience, I know the content you really want is SpreadsheetCon. Enough with the hacking establishment taking over HackerCons. We're here to talk about spreadsheets. All right, so who am I? Why would you listen to me? Why am I here telling you things? I'm Josh Brodie. I am a former penetration tester, now working as a security architect for the Bird app, which is a popular moniker everybody uses to refer to TradeMe because of the bird in our logo. I am Josh Brodie and Zed on various internet places. You may have seen me loudly opining about all manner of things. So I want to just do a bit of audience interaction here. I just want to know how people feel about vulnerabilities and exploits for those vulnerabilities. Can I get a show of hands of people in this audience who, when a new CVE drops, CVSS 9.8, the world is on fire, raise your hands if that feels good to you, if that's an exciting day. All right, now of those with your hands raised, keep them up. Lower your hands if you are then responsible for tidying up after that. Yeah, only a couple of hands dropped. A lot of red teamers in the room. I used to feel that way. New vulnerability dropped. I went, great, new tool in my toolbox. This is amazing. Gonna get so many shells. Within my first month as a penetration tester, this little beauty popped up. Shell shock. I was on holiday at the time, and I just went, all right, I did take a holiday within my first month of being a pen tester, but I looked at this popping up in the news and went, when I get back to work, it's going to be a beautiful thing that's going to be everywhere. The reports are going to write themselves. Amazing. Within my first week of being a defender at TradeMe, Log4j. For those who aren't familiar with either of those vulnerabilities, both cases where the powers that be, I guess the cyber cops, it was widely considered that the internet was on fire for both of them. Very different experiences, and based on my newfound respect for having to tidy up after vulnerabilities, I would like to suggest a controversial idea that perhaps vulnerabilities aren't great. I don't care for them at all. I think we should stop doing them, to be quite frank with you. No more, cut it out. Because the experience as a penetration tester is you generally run a vulnerability scan as part of any given engagement that you're doing. It's just, par for the course, chuck one in alongside it to catch all the easy to find things and make sure your coverage is good. And so day by day, you're just kind of yeeting these vulnerability reports into the void, lobbing them at customers, going, yeah, enjoy it. You kind of just, you swan in, you say, here's everything that's bad. You charge them $3 bazillion, and then you move on to the next one. It's just kind of you might do a bit more if you're a good pen tester, but that's the gist of it. What you don't consider when you're on this end of the fire hose is that the other end of the fire hose, it's not as much fun. It's not great. And at TradeMe, a lot of people are getting a penetration test and an associated vulnerability report once a year, every 6 months perhaps. There isn't a point in time where we're not running scans against ourselves at TradeMe, so this is coming in all the time. There are computers just shouting at us, here's the things you need to know about. Mostly they're wrong, but they don't stop saying it. So why automate vulnerability management? Largely because of that volume that I'm talking about, but also in security professionals, there aren't a lot of us for how much work there is. We're expensive people to have on the team, and sitting there manually curating a feed of things a computer thinks might be bad is not a good use of our time. I've worked with organizations who spent a lot of their time trying to figure out how to even start triaging their list of vulnerabilities. So I worked with organizations who had a spreadsheet containing 3.5 million things a computer said might be wrong in their environment. And I spoke with them one year about how they were starting to go through that and figure out, what do we need to look at first on this list? What are the things that are actually critical things we need to address right now? And I spoke with them a year later, and they said, we've almost figured out how to start reading the spreadsheet. We're almost there. So that's the problem that I was trying to solve. You get one of these, the output of one of these tools is something like this. It's a long list of, here are the things that are bad, here is where the thing that is bad is based on an IP address, here's how to fix it, associated metadata. But largely it's not a particularly friendly way to consume that information. And if you're a security professional trying to get developers and teams to fix things that are within their sphere of influence, just kind of lobbing the spreadsheet at them and going, here's a bunch of things a computer said, they're going to disengage from the security team in the process of fixing things. So what I want at the start of this process is something a bit more like this. I want for each developer team within our organization, I want to be able to give them a curated list of, here are the things that matter for your team. And ideally I want them, because we're getting this information continuously, I want them to be able to at any given time look at this and have an up-to-date to-do list of the stuff that needs to be addressed, or even if it's being addressed, just the stuff that is potentially an active threat in the environment so that they can work around it and be aware of it. I think to myself, what's the best way to manage this information? As any problem that feels like it might be able to be solved with a spreadsheet, I'll try and solve it with a spreadsheet. I can probably do this with a pivot table. If I add next to each vulnerability which team needs to be addressing it, I can split it out into smaller spreadsheets and I can give those to the team, problem solved. Given that I titled the talk Life Beyond Spreadsheets, you may be able to make some assumptions about the fact that my process escalated a bit further than that. So at this stage, all I need to do is convert a list of vulnerabilities by IP address into a list of vulnerabilities by system owner. Simple. Sounds easy. No worries. Reader, it was not. So why was this hard? What makes this a more difficult problem than it seems on the face of it? For starters, the volume again. There's a lot of tools that we're using to tell us security information about our environment. These ones in particular are the ones that I'm working with. We've got 9 different tools, all of which we're using each of them for a reason. There's at least 1 or 2 things that they are uniquely good at telling us that we need to know. And then the overlap between all of these tools is enormous. And so a minor misconfiguration based on the standards that they're all using will be reported by all of these tools across all of our assets at the same time. So we've got 9 sources of security information run continuous scans against us across 360 plus GCP projects, and we are just looking at GCP. We are a multi-cloud primarily in GCP. 360 plus compute instances, 2,300 Kubernetes pods with just containers everywhere. We've got 160 plus cloud run services, and when I look at Tenable.io, it says it's got information for 14,000 hosts. And Tenable isn't even looking at our corporate environment. So according to these tools, there are 360,000 vulnerabilities across all sources. I do have to put vulnerabilities in scare quotes because I am going to ask that the next slide not get shared out of context. 360,000 vulnerabilities. It sounds really bad. Not as bad as that 3.5 million I was dealing with previously. But do I need to be worried about this? But when I dig into it, most of this is hardening recommendations that don't apply to our environment, multiplied across 9 tools, multiplied across all of those hosts. There's a lot of duplication in there that we don't need to be dealing with. And further than that, most of this is stuff we've already looked at, but because we've got all these different sources of information telling us, there's no consistent way to tell every tool, stop telling me this, you're wrong. You can say, it'll pop up again every time you tell it this. So we need a better way to track what are the actual things that need to be addressed now. If you've just got a one and done spreadsheet, you can go through and check it off. That's a lot easier, but we're updating this, every hour with another refreshed dump of these things are bad. So the vast majority of these vulnerabilities are noise that we don't want to surface to our teams. The vast majority of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulnerabilities are noise that we don't want to surface to our teams. 99% of these vulner For this process, I start by taking these sources of security information and reducing it down to just a couple of the ones that give us the best signal. So I'm just going to automate Google Security Command Center, Tenable, and I want somewhere to store pen test findings because we're investing a lot in getting those done. The output is generally quite high quality. That is stuff that the team needs to have available. So we've got a lot of information, and then we're giving it to the teams. So we've got 600 staff across 40 developer squads, serving 5 functional business verticals. There are 15 customer-facing products, some of which are owned by a combination of teams. So the database team need a different list of findings to address than the front-end team, than the infra team. So even though I've got an IP address with a finding, different people need to handle that information. And then there are additional internal products that are within the scope of this work. So what I'm saying is I need to convert a big list of vulnerabilities by IP address into a big list of vulnerabilities by system owner and deduplicate findings if tools report the same issue. It still sounds like, a spreadsheet can do that. I'm going to have a lot of hidden lookup sheets in the background, but I can make it work. You'll note I said that there were 14,000 hosts in Tenable, and that's not what happens when you sum the number of hosts that I said we had in the cloud. So why doesn't that add up? The issue here is ephemeral hosts. So these tools are saying there is a vulnerability at 10.1.1.4. Within our environment, most things are spinning up and down throughout the day. VMs and containers and other units of compute are being created and destroyed all the time to scale to our demand. We might push out a new deploy, and so we kill every bit of compute we've got. We spin up a whole nother copy of the environment. And every time that happens, it comes back with a new identity in a new place. And the tools we're using say, oh, another 100 computers. But they don't forget about the previous ones. They don't know that they've gone. Or some of them might, but in inconsistent ways between the tools. So the problem I need to solve first is how I'm going to figure out who is responsible for each finding in this list of 360,000 entries. I try a number of different things here. I'm going to run through why they all didn't work. I thought maybe I could interrogate our cloud APIs and I can find out which product or cloud the assets live within. It turns out that this only really works for live hosts. There's no guarantee of no collision between internal ranges cross-cloud. The teams are generally pretty good at saying, if we're using 10.1.1.x for this project, we're not going to use that anywhere else. Generally, but can I count on it for this tool? And additionally, from time to time, we'll acquire another organization, and they're probably using an internal range that we might already have things on. So it's not a reliable way to say which assets we're talking about. I thought perhaps I could have a script read our infrastructure as code, which defines the subnet ranges that each project exists within. So we've got our entire environment is config files that a computer takes, and it goes and builds us an environment based on those. So we say where we want things to go. Maybe I can use this. That turns out to also be a very error-prone approach. It doesn't work for projects that deviate from that standard. It doesn't, again, work for businesses that we might acquire who aren't using our infrastructure as code standards. And it puts constraints on the infra team to never change how this is defined because I built something off the back of it without telling them. It's not going to do the job for us. I figure perhaps I can map the IP addresses to our system inventory and find out whose product it is. But at the time that I start this project, our system inventory doesn't have that information in the way I need it. And the migration to one that does is an ongoing process. So our system inventory, it might even be a future talk. It's kind of evolving into something that meets this demand alongside this vulnerability management program. I thought maybe I could just use the name of the scan in Tenable. We've got a bunch of scans called PayStation or MotorWeb. That tells me who's responsible for it. In some cases, I can maybe use that, but our largest scan is called Full External All ASN All Domains. And everybody owns that. I want this process to be agnostic regarding the source tool as well, so that I can add more tools easily in future. So it needs to accommodate tools that don't know where the asset came from. Additionally, the full external scan, I could break it up, but it predates our move to the cloud. It's got a lot of kind of trend and history associated with it that we actually get value out of keeping in one scan. And it's got 7,000 assets that might not be live now, but they're IP addresses and domains that we do own. And I want to know if something pops up on it that we weren't accounting for, being spun up again. That's not going to do the job. I thought maybe I could just use a really long series of nested if statements to combine all of those earlier ideas into one. When you are making that many if statements, I'm given to understand that you can call it AI and put that on your CV. Because I'm not a clever man, I start working on this. It's immediately clear that it is not a maintainable way to solve the problem, as evidenced by your laughter at the mere idea of doing so. Ultimately, what I land on for now is a bit of a trade-off. The GCP findings say which project they're coming from. So from SCC, I know who the owner of that is. We've got metadata about that. And I can use that information and import that into Tenable, tagging those assets so that both Tenable and GCP know where these findings are coming from, and then use this kind of manual attribution work to bootstrap the process going forward so that all of our other tools can take advantage of the fact that we've done it this one time. So at this point in time, I'm still thinking when you use a spreadsheet, it still feels spreadsheety. It's at this point in any given project, I believe, that you start to let your dreams get ahead of your ability, and scope creep sets in. Now that we've got the idea this far, it could do a whole lot more things. We want to be able to track decisions about vulnerabilities throughout the vulnerability lifecycle. We've got this problem with these 360,000 entries that we've already made decisions about, but we didn't have a consistent place to put that decision in a way that all those tools were aware of. So I want to be able to say for each vulnerability, did we accept the risk? Are we fixing it? Did we mitigate it, and how? What's the current status of our decision-making about this vulnerability? I also want more context for triage of vulnerabilities. I want to know how critical is the asset to our operation? How many user records are in that system? Does it have PII? Is it in our PCI scope? All of these things change how important it is to fix the vulnerability right now. What about access control? We're security people. It's not really appropriate for these 40 developer squads to all have visibility over the vulnerabilities in each other's products. It doesn't feel great. So no, we're going to need access control so that each team can only see things within their sphere of influence. We also want vulnerability SLA and vulnerability SLOs within vulnerability SLAs, so that for each finding, based on the criticality of the asset and the severity of the finding, I can say, if there's a critical vulnerability in a crucial system, I want this process to automatically say, you've got 2 days to fix it. If there's a minor low severity finding in a minor system, I want it to automatically say, you've got a bit more leeway for when you need to fix this. Additionally, I want it to automatically do finding deduplication between different tools. So if 9 different tools say there's a self-signed certificate on some internal thing that we're not worried about, I want that to show up as one finding. A spreadsheet's gonna have a hard time of doing this, but what I'm looking for now is essentially for each finding in this breakdown, I want to know, have we made a decision about accepting the risk, or are we fixing it? Why did we make that decision? When are we going to revisit that decision? And I want it to automatically surface and say, okay, we decided to accept the risk because it's not exposed on the internet. If it becomes exposed on the internet, though, we need this to be popping up now and then and saying, hey, is that still true, or has this suddenly become bad? I want to know who made that decision. Did they have suitable visibility over the product? Did they have suitable seniority to accept that risk on behalf of the business? How important is the system? How many days did we want to fix this within? And did we? So that we can start to track how we're trending on meeting those targets. So as I say, this is getting out of the realm of what I won't say can, but should be done with a spreadsheet. It's at this point that my boss Kate lets me know we've got a kind of proof of concept version of a tool that might do some of these things that we stood up some time ago before I started. And I should start having a poke around with that and see how it does. So it's at this point that I learn about the OWASP product, DefectDojo, which is an open source platform for vulnerability management. I put it in the title of this talk, so you already know that I picked it as the way to solve this. So what kind of things does DefectDojo do for us that kind of leads to me making that decision? It will, out of the box, import findings from a variety of sources. All of the common ways that security professionals run automated tools to find security information, DefectDojo has a parser where you can just throw the report at it, it pulls it apart, and it converts it into its internal format. So that's handy. It allows us to record a justification for any risk and severity assessments we make on each finding. If the tool says it's a high and I say it doesn't know what it's talking about, it's a low, I can write in why I thought that and kind of record that for posterity. It will automatically deduplicate findings between tools, and I can tick a whole lot of findings that it doesn't know about and say, hey, if you ever see these again, they're the same thing, stop telling me about them. It also gives us a forum to comment on and discuss vulnerabilities with teams, so the teams can click a button on the finding to ping the security team, and they can say, hey, I want to revisit something about the decisions we've made about this finding, and we can record our conversation about the finding in line there. It'll let us track risk acceptance decisions, and it will automatically, periodically resurface them for review. It will let us track timelines for issue closure, and a update that was made to the product while we were setting this up was it'll allow you to set different targets and timelines based on finding severity and product criticality. Lets us do access control. Amazing. I'm repeating my list of things I want it to do, because those are the things that it does. It'll allow us to easily report on the performance of our vulnerability management program to different levels of the business. We can say, the executives might just want to see how many vulnerabilities are in our opponent systems now, or how are we trending on addressing vulnerabilities in the timeframes that we're committing to addressing them. We can report on all of that out of this tool. And it'll also give us other security context to inform incidents, so that if we've got something going wrong or a serious vulnerability in a product, we've got all of the relevant context right alongside it about, yes, we've got this thing on fire, but is it made of gunpowder? So what we've got set up now is, I've got a magic script out there in the internet, because there is some business logic we need to apply to this at the moment. I'm trying to move as much as we can into DefectDojo itself, partially so I don't have to maintain a magic script, and partially so that might be useful to other organizations using it. Mainly what the magic script does is, if a finding is common to our templates, not to the project itself, it'll strip that out and assign it to the template. So this will go out to the APIs of Tenable, the APIs of Security Command Center, import everything into DefectDojo, and we also add pentests in there as well. I will confess pentests are currently imported as CSV, which is spreadsheet adjacent, but we're ignoring that for the purposes of this talk. We are beyond spreadsheets. So for our environment, we've got a list of different business units who can see at a high level what the status of findings in their business unit is. We can see for each business unit, this is redacted real information. So if I missed anything, you didn't see it. We've got a list of products in that business unit. For each product, we can bring it up and we can see all that security context that I mentioned previously, who's the owner of various responsibilities within that product, so that we can contact them, what vulnerabilities are in it, what regulations apply to the product, what technologies are in that product. We get a list of findings and a quick view of how they're tracking for being addressed by the SLA. And then within each finding, you get all the normal stuff you expect out of a penetration testing report or a vulnerability scan. When was it found? Where was it found? How do you fix it? All that good stuff. So what my future state is going to be is lining it up so that each of those additional tools that we're using are being fed through the magic script into DefectDojo, so the teams can see them and we can prioritize our addressing findings that way. Additionally, alongside pen tests, I want our application code analysis during our CI/CD pipelines to be flowing through into DefectDojo automatically so the teams can consume and address it there. We're at time, but the key takeaways I will quickly blaze through. After the vulnerability scan is delivered, I found that the actions to address it, when you're on the pen testing side, you expect that there's a lot of technical work that needs to be done. But the internal business communication work to even get that finding to a point where it can be addressed is a lot more complicated, often even more so than the technical addressing of the finding itself, is just the internal movements of the business to get to a point where you can do that. Implementing a vulnerability management program is mostly an exercise in internal communications. There's a little bit of security that you do in the middle, but it's otherwise an illustration of Conway's law, which is any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. This entire exercise was essentially taking a bunch of technical tools and forcing them to adapt to the structure of our business and the communication lines that exist within that business. Although it took quite a bit of work to get it to adapt to our specific purposes, OWASP's DefectDojo was a far more powerful platform than any of the commercial alternatives we considered for this. We've been really impressed with how it's handled this. I also found the eternal lesson, I might just be speaking for myself, but hackers, mainly me, are rather sketchy sysadmins. So I am wrapping up there, but if you want to chat afterwards about how I introduced this product to the teams, got them all on board, told them to put their important data in it, and then blew the whole thing up because I'm bad at computers, we'll have that conversation. If you've got questions, if you've got comments, stories about how you solved this problem at your organizations, you thought of a really good heckle, I'll pretend that you came up with it in the moment. We'll do that afterwards. Thank you.